Hello students, in this video we will be studying about the hyperbolic orbits. So in this section, while doing the hyperbolic section, we will apply the motion of an extrasolar comet about a sun, which is a hyperbolic orbit. Also, we can apply this hyperbolic paths to the trajectory of a charged particle scattering off an atomic nucleus, because the electric force and gravitational force are both inversely proportional to r square. So in both these cases we can apply the hyperbolic orbits. So we know that if we take a particle or let it be a comet of mass mu, it is coming initially with a velocity v0, and when it is at far away origin, okay, this is the interaction area, and b is the distance, which is commonly called the impact parameter. So this is the initial path and it gets deflected towards this direction. Okay, so we know the angular momentum L is equal to mu v0 p, and total energy is half mu v0 square, which is the kinetic energy. Okay, before it comes to interaction, if there is an inverse square law force like gravitational force or the Coulomb force, we know the potential energy associated with will be minus E by R, which we have studied in the previous video. Okay. So from that we know the equation of orbit is R is equal to R0 by 1 minus epsilon cos theta, where epsilon is the eccentricity. Okay, we know that R0 is equal to L square by mu C. And on substituting L from this relation, you get L square by mu C, or R0 is equal to mu V0 square B square by C. Now we substitute mu V0 square from this relation. Mu V0 square is nothing but 2E, or you can substitute it like this, 2EB square by C, which is also equal to R0. And also eccentricity has the form equation root of 1 plus 2EL square by mu C square. So here also we substitute L is equal to L square is equal to 2 mu E B square from the relation which I have read earlier. So on substituting you get the equation as root of 1 plus 2EB by C square whole square. Okay, so we get the eccentricity. Now when theta is equal to pi, you get R is equal to R minimum from our orbital equation, or this equation. When theta is equal to pi, R becomes the minimum distance. So when theta becomes pi means the particle or the comet will be at this point. Then only theta becomes pi value. Okay, this is the minimum distance up to which the particle reaches the interaction. Okay, so R at that angle, R will be equal to R minimum. Therefore, R is equal to, our equation becomes R0 by 1 minus epsilon cos theta becomes, cos theta is cos pi, which is minus 1. So our equation becomes R minimum is equal to R0 by 1 plus epsilon. Substituting for R0 as 2EB square by C, and epsilon from the relation 1 plus root of 1 plus 2EB by C whole square. This is the equation for the minimum distance up to which the projectile reaches the interaction point. Okay, so for when E is much greater, or when E tends to infinity, you can solve this relation and you get the value to be minimum. R minimum is reaching the value B in this equation. Okay, so from 0 to infinite energy, the value of R minimum will be between 0 to B. So the minimum value it can attain is nothing but B. Now if in the two asymptotic cases, if this is the initial incoming direction and this is the scattered direction, these two lines are making an angle of pi minus 2 theta a. Theta a is the angle, the equal angles dividing the axis. Okay, so this psi. So from this asymptotic relation, that is when r tending to infinity, when r is tending to infinity, you can find the relation of cos theta a as equal to 1 by epsilon from this relation. Okay, when r tend to infinity. So in the interaction, when mu is deflected through an angle, psi is equal to pi minus 2a. This angle psi is called scattering angle. In nuclear and atomic physics, we call this angle the angle through which the incoming particle gets scattered, which is this angle pi minus 2 theta a, which is psi. This angle is called the scattering angle. So according to the sketch, psi is related to theta a as psi is equal to pi minus 2 theta a. Since theta a is related to eccentricity, psi is also related to eccentricity. Okay. So we find what is cos theta a. From this equation, theta a is nothing but pi by 2 minus psi by 2. Okay. So cos theta is equal to cos pi by 2 minus psi by 2. So cos by this is 90 minus theta, which is sine psi by 2. Okay. So we know that cos theta is equal to 1 by epsilon. On substituting that, sine psi by 2 is equal to 1 by epsilon, and substituting for epsilon, you get it as 1 by root of 1 plus 2 EB by C whole square. You get the relation of the scattering angle with the impact parameter and energy of the particle. The scattering angle psi approaches 180 degree if this term is much less than 1. Okay, the scattering angle becomes 180 degree if this term is much less than 1. This is the behavior of a hyperbolic orbit.